Right now, we are looking at Earth from space. Every person who has ever lived, every civilization, every moment of human history, all contained on this single world. But today, we embark on a journey of unimaginable scale. We are traveling 10 billion light-years across the universe. Our destination is TON 618, one of the most massive black holes ever discovered. To reach it, we must transcend the limits of light itself, traversing cosmic distances that defy human comprehension. This voyage will take us to the very edge of the observable universe. There is our sun, the star that has sustained life on Earth for billions of years. It is a beacon of warmth and energy, the heart of our solar system. But out here, in the cosmic ocean, it is merely one among hundreds of billions of others. Each of these countless stars likely hosts its own retinue of planets. Rocky worlds, colossal gas giants, and frozen moons populate these distant systems. Some of these planetary families might even harbor life, though their secrets remain forever beyond our reach. TON 618 lies over 10 billion light-years from Earth. The light we perceive from it today began its journey when the universe was only 3 billion years old. This ancient light predates the formation of our solar system and the very existence of life on our planet. That glowing band of light ahead is the center of the Milky Way, our home galaxy. Here, hundreds of millions of stars orbit in a dense, luminous cluster. At its heart resides Sagittarius A, the supermassive black hole anchoring our galaxy. Sagittarius A weighs approximately 4 million times the mass of our Sun. It is a colossal entity, yet it pales in comparison to our ultimate destination. TON 618 boasts a staggering 66 billion solar masses. This makes TON 618 more than 15,000 times heavier than the black hole at our galaxy's core. It is a true titan, an anomaly even among the most extreme objects in the cosmos. TON 618 does not reside within the Milky Way. It lies far beyond our entire local group of galaxies, far beyond Andromeda. It exists in a region of space so distant that only the most powerful telescopes can glimpse its ancient light. It is humbling to consider that everything humanity has ever known exists within our galaxy. The Milky Way is a barred spiral galaxy, stretching 100,000 light-years across. It is our cosmic island, a vast collection of stars, gas, and dust. But now, we leave its familiar boundaries behind. This is intergalactic space, the immense void between galaxies. No stars exist out here, only the faint, scattered glow of distant galaxies. The Milky Way is now just one galaxy among billions of others. From this vantage point, it is easy to forget that this single spiral contains everything we have ever known. Our solar system, every star we have ever named, every planet we have ever discovered, all contained within that pale, receding structure. TON 618 lies billions of light-years further ahead. The Milky Way is now far behind us, a faint memory in the cosmic tapestry. Every second, we cross millions of light-years. Light itself would take millions of years to cover the same immense distance. These points of light passing by are not stars. They are entire galaxies. Each one contains hundreds of billions of stars, countless planets, and possibly life forms we may never encounter. This is what most of the universe actually looks like. Empty space, intergalactic voids stretching between distant galaxies. If you were truly out here, you could travel for millions of years and see almost nothing. Intergalactic space is so empty that there is less than 1 atom per cubic meter. No stars, no planets, no dust. Just the faint light of galaxies, separated by incomprehensible distances. Some of these galaxies are spirals, like the Milky Way. Others are elliptical, shaped like giant spheres of stars. Some are irregular, their forms distorted by collisions with neighboring galaxies. Almost every galaxy harbors a supermassive black hole at its center. These range from millions to billions of times the mass of our Sun. But none are as massive as the one we are traveling toward. The further we travel, the further back in time we are looking. Light from these distant galaxies left billions of years ago. We are seeing them as they were in the ancient past, not as they are today. Some of these galaxies might not even exist anymore. The light we are seeing could be from galaxies that have since merged with others or had their stars stripped away by gravity. Our destination lies in a region of space that, from Earth, appears in the constellation Coma Berenices. But it is not nearby like the stars in that constellation. It is billions of light years beyond them. TON 618 was first noticed in 1957 by astronomers at the Tonantzintla Observatory in Mexico. They cataloged it as object number 618 in their survey. Initially, they thought it was merely a faint blue star, but it was not until 1970 that astronomer Marie-Helene Ulrich measured its spectrum and discovered its true nature. Those emission lines were shifted far into the red, meaning it was incredibly distant. It was not a star, it was a quasar. Quasars are the brightest objects in the universe. They are powered by supermassive black holes actively consuming matter. As gas and dust spiral into these black holes, the material heats up to millions of degrees and releases enormous amounts of energy. TON 618 is one of the most luminous quasars ever discovered. It shines with the light of 140 trillion suns. That is thousands of times brighter than our entire Milky Way galaxy. Here is what makes it even more remarkable. We are seeing this quasar as it was over 10 billion years ago. A black hole this massive already existed when the universe was still young. Scientists are still trying to understand how it grew so large so quickly. To grow a black hole to 66 billion solar masses in just 3 billion years, it would need to consume matter almost continuously. There are theoretical limits to how fast black holes can grow. This object pushes against those limits. Some scientists theorize it formed from multiple smaller black holes merging together. Others believe it started as an unusually massive seed black hole, formed from the direct collapse of enormous gas clouds in the early universe. We are approaching a region with higher galaxy density. This is common in the universe. Galaxies cluster together in groups and larger structures called superclusters. Our Milky Way is part of the local group, about 30 galaxies bound together by gravity. The local group is part of the Laniakea supercluster, containing about 100,000 galaxies. Our destination lies far beyond all of this. The galaxy we are approaching is completely overwhelmed by the quasar's light. The black hole at its center is so bright that it drowns out the billions of stars in that galaxy. From Earth, even with powerful telescopes, we only perceive the brilliant point of the quasar. But the galaxy exists, a massive galaxy with billions of stars orbiting that supermassive black hole at its center. Surrounding the quasar is an enormous nebula of glowing gas stretching hundreds of thousands of light years across. We are now over 10 billion light years from the Milky Way. If we looked back, our home galaxy would be invisible, lost among billions of others. Earth, the Sun, everything humanity has ever known, reduced to nothing in the cosmic vastness. the light we are approaching left when the universe was a quarter of its current age. Dinosaurs would not appear for another 10 billion years. Humans would not exist for almost 13 billion years. And yet this black hole was already there, already massive, already consuming matter and shining across the universe. Ahead of us, one point of light is growing brighter than the others, brighter than any galaxy around it. That is TON 618, the galaxy containing one of the most massive black holes ever discovered, its center blazing with the light of the quasar, a beacon that has been shining for over 10 billion years. We have traveled across more than 10 billion light-years of space to reach this point. And now, finally, we are approaching the galaxy itself. This massive structure has existed for billions of years, its central black hole consuming matter and powering one of the brightest objects in the universe. We are almost there. We are entering the galaxy now. This is a massive elliptical galaxy, home to hundreds of billions, possibly up to 1 trillion stars. Unlike spiral galaxies, elliptical galaxies do not have distinct arms. Their stars orbit in all directions, creating a more spherical shape. This galaxy has existed for billions of years, likely growing larger by absorbing smaller galaxies over time. The quasar at the heart of this galaxy is so bright it drowns out the stars around it. From Earth, astronomers can see the quasar, but not the galaxy itself. The galaxy is there, but the black hole's light is too overwhelming. We are almost at the center now. There, two massive jets shoot out from the poles. These are beams of particles and energy blasting away at nearly the speed of light. These jets stretch thousands of light years into space. This is how quasars work. Not all material falling toward the black hole crosses the event horizon. Some gets caught by powerful magnetic fields near the poles and is ejected outward instead. The jets are powered by the black hole's spin and the magnetic fields in the accretion disk. They are so energetic they can affect entire galaxies, heating gas and changing how stars form. That intense glow ahead is the accretion disk. Gas and dust spiraling into the black hole, heating to millions of degrees as it falls inward. The closer material gets to the event horizon, the hotter it becomes. The inner regions glow white-hot. Farther out, the disk is cooler, but still hotter than most places in the universe. The event horizon lies ahead, the boundary where nothing can escape. Its radius is about 1,300 astronomical units, over 40 times the distance from our Sun to Neptune. Time moves differently this close to the event horizon. The stronger the gravity, the slower time passes. Near the boundary, time nearly stops. This black hole weighs about 66 billion suns, roughly the same as all the stars in the Milky Way combined. And all that mass is packed into a region smaller than our solar system. Its gravity bends light itself. We can see parts of the accretion disk that should be hidden behind it, because space is warped around the black hole. Cross the event horizon, and there is no way back. Everything that falls in is pulled toward the singularity, where physics breaks down completely. This is the universe at its most extreme, where gravity is absolute, where time bends, and the rules of physics cease to exist. This is TON 618.